All right, another story problem. Woohoo! Please again make sure that you're keeping track of how many you scored on your own so that I can have an idea and you can have an idea of where you're at with these problems. All right, the rate at which people enter an auditorium for a rock concert is modeled by the function R given by that formula for 0 to 2 hours. R is measured in people per hour. No one is in the auditorium at time t equals 0 when the doors open. The doors close and the concert begins at time t equals 2. So how many people are in the auditorium when the concert begins? So first thing, I want to know how many people, and I know that R is measured in people per hour. So to get from people per hour to people, I know that I'm going to take the integral, and I'm going to take the integral of R of t, and I'm going to, it started at 0 and then it went to 2, so I'm going to take the integral from 0 to 2. I get to use Math 9 because this is still a calculator problem, and if I do that I should get 980 people. I would have to consider if anyone was in the auditorium at time equals 0 when the doors open, I would have to add that to that, but I don't have to in this case. All right, this problem was worth 2 points. You got 1 point for having an integral set up, and you got 1 point for saying that there were 980 people. Please make sure again on your integral that you do include limits. All right, part B. Find the time when the rate at which people enter the auditorium is a maximum and justify your answer. Okay, if I want to know when the rate is a maximum, the rate is R. If I want to know when R is a maximum, first thing that I need to do is find where R prime is equal to 0. So we're trying to find a critical number here. To figure out where R prime equals 0, we do get to use our calculator. So what I would do on this one, let's see, I could go ahead and find R prime. Let's see, R prime is going to equal 2,760, I believe, t minus, let's see, 675 times 3 will be 2025 t squared, and then I'll set it equal to 0. To figure that out, we could graph it and use the 0 feature of our calculator. That would be the easiest thing to do. And when we do that, we should get t equals 0, and we should get t equals 1.363. All right, so now once we get our critical numbers, if we're looking for a maximum and we're given an interval, so we're given from 0 to 2, we're actually going to find R of 0. We're going to find R of 1.363, and then we also want to find R at our endpoints. We're already finding at one of them. Let's find it at the other one at 2. Okay, so I'm actually going to find those values, and to find those values, R of 0, you just plug 0 in for the R. R of 1.363, just plug that in for the R, and R of 2, just plug that in for the R. When I do that, when you plug in 0, you get 0. When you plug in 1.363, you're going to get 854.527. And when you plug in 2, you get 120. The question was find the time when the rate enter the auditorium is the maximum. So it didn't say what is the maximum, it said find the time. The time is going to be 1.363. Okay, so we get 3 points for that one. Okay, if we considered the derivative equaling 0, so if somewhere on your paper you have R prime equals 0, that's going to equal a point. It's going to be 3 altogether. You're going to get 1 point for finding your critical point. So if you actually find 1.363, you get another answer. And then your third answer is going to be if you did this justification to show that 1.363 was actually maximum. So that was your third point for that part of the problem. Okay, part C. The rate at, the total wait time for all people, notice this is a very wordy problem, but don't worry about it, just kind of read through it. For all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the total wait time, so we didn't have to come up with a formula. They're telling us that this is the formula for the wait time. The derivative of W is given by W prime. So W is the total wait time. This is the W prime. The total wait time, and then it says, let's see, find W2 minus W1, the total wait time for those who enter the auditorium after time t equals 1. So I notice that they're asking me to find W2 minus W1, and hopefully that's looking somewhat familiar to you. It's kind of the fundamental theorem of calculus. I'm going to put the integral. I know I want to evaluate it at 2 and 1, so I'm going to put 1 and 2, and I'm going to put W prime inside. And remember, the reason that we're going to do that is because if I do the integral of w prime, that's just going to leave me at w, and then we get to evaluate it at the 2 and 1, I'm going to get w2 minus w1. All right, now to get this left side right here, we know an equation for w prime. They give it to us right here. So we can actually use Math 9 to get that answer. And when we do that, we should get 387.5, and that will equal w of 2 minus w of 1. And this time we're usually given one of those when we want to find the other one, but they actually told me to find w2 minus w1. So we have w2 minus w1 equals 387.5. So 387.5, and then we should put hours, is my right answer for that one. So let's see here. How many points is this one worth? This one is going to be worth 2 points. If you set up an integral, like what I did, just 1 to 2 of w prime, you're going to get a point. And then if you came up with the right answer, you're going to get a point. So that was worth 2 points. All right, final part. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. Okay, if I'm thinking about this, I'm guessing if I could figure out the total wait time and then divide by how many people were in the auditorium, that should give me how much time per person, or how much time per person. So what we are going to do, we're basically just going to go 0 to 2 of w prime, and we already found that that was 387.5, so that was the total wait time. And actually, that was not correct. This one, that's not the same answer, because this one just went from 1 to 2. We actually want to start at 0 to 2 from when they started getting into the auditorium until the concert began. So the integral from 0 to 2 of w prime, if I use Math 9 to get that, I'm going to get 760. And then I'm just going to divide it by how many people there were. There were 980 people. So each person had to wait 0.77, I wrote that better, 0.776 hours. So on average, that's how much a person had to wait. And to get that, that was worth 2 points. First of all, you're going to get 1 point if you set up the integral for going from 0 to 2, because we were talking about wait time. And then if you got the right answer, 0.776, you got your second point. So hopefully you did all right on that problem too.